So today we're going to talk about how to simplify radicals. We're also going to talk about, what is a radical, why are we simplifying these things, all that kind of stuff, and what you know about them from before. Okay? So let's just go into some basics here. So the first thing is, what is a radical? What is a radical? So you actually know what a radical is, although you've never heard that term possibly before, and it's basically what this is right here. So what is this right here? And you're like, oh, okay, I know what this is. This right here is a square root symbol, right? You've dealt with square roots before in the past. Okay? However, we don't say that's a radical, so basically the actual definition of a radical is a root. But we don't always just say square root. Now, in algebra, we will only be dealing with square roots. 100% true. But later on in your math career, you'll be having cube roots, or fourth roots and fifth roots possibly. And you're not used to those yet. You're only used to the square roots, which is fine because that's what we're talking about here. Okay, so radical is a root, and in algebra we're only going to be dealing with square roots. Okay, so let's talk about perfect squares real quick because it's going to come up, and I want you to write these down. You have got to memorize these basically just from math. So for example, 2 squared is 4. 2 times 2 is 4. Okay? So the square root of 4 would then be 2. You can go backwards. 3 squared is 9. I know you know these, I just need you to write them down. 4 squared is 16. 5 squared is 25. 6 squared is 36. Yet again, I'm sure 100% you're aware of this, but I need you to write them down. 7 squared is 49. 8 squared is 64. 9 squared, 9 times 9 is 81. 10 squared is 100. 11 squared, 11 times 11 is 121. 12 squared is 144. And we could keep going. 13 squared is like 169, or 14. You could keep going for a long time, but these are the main ones you should know, your perfect squares. Okay? So I should know that the square root of 25 is 5, or the square root of 100 is 10. Those are things that you should know. Or if not, you need to look on this chart. Okay? So let's kind of refresh what you've done before, and then add a couple things to it. So this right here, this means the square root of 64. Now you've done this before in previous math classes, and you'd say, okay, well the square root of 64 would be 8. Right? Because 8 times 8 is 64. That is perfectly correct. You're right. However, what you're going to have to start writing in algebra is you're going to have to put a positive 8 or a negative 8, plus or minus 8. We normally write it like this. You could also write it, if you wanted to, like this, a positive 8 and a negative 8. Okay, plus or minus 8. And here's why. 8 times 8 is 64. Okay, that is 100% true. But negative 8 times negative 8 is also a positive 64. So you have to write a plus and a minus. Always. So if this is a perfect square, when you pull it out, plus or minus 8, or a positive 8 and negative 8. This is the way we're going to start wanting you to write it, but it's the exact same thing right here. Okay? Because it makes sense for both of them. So same thing here. Square root of 4, well that's easy, that's 2. But it's not just 2, it's a positive or a negative 2. Plus or minus 2. You don't know which one it is, could be either one. Okay? Square root of 25, obviously it's 5, but it's either positive or negative 5, not just positive 5. It could be negative as well. Okay, so you get 2 different answers there. And then 121, the square root of 121 is 11, but yet again, positive or negative, because 11 times 11 is 121, but negative 11 times negative 11 is also 121. So those are super easy to simplify. You're already thinking, this is going to be the easiest lesson ever. No, okay? Because then the next thing is, what if it is not a perfect square? And this is what you haven't really had to do before. What if it's square root of 20? Square root of 20 does not have a perfect square. Because, 4 is 16, 5 is 25, it's somewhere in the middle. It doesn't have a perfect square. And we want you to simplify this. So what you used to have to do is, okay, well, I'll give you a decimal. I'll round it, it'll be about right, I'll give you a decimal. No, we don't want a rounded answer. I want a simplified answer, and that is what's really new about today's lesson. Okay? We're going to do that by something called prime factorization. Okay? basically a factor tree. We're going to make a factor tree. So I'm going to do my steps here, and I'm going to do my work here. So step 1 is I want you to make a factor tree. I want you to make a factor tree. Okay, so what multiplies to 20? You can think 2 and 10, 5 and 4, however you want to do it. I'm going to go ahead and do 5 and 4. It doesn't really matter though if you do 2 and 10, we get the same thing at the very end. I cannot break up 5 anymore, but I can break up 4 into being 2 and 2. Okay? And I can't break up anything else. I can't break up the 2's. I've made my factor tree. I am done. Okay? Now, there's a couple different ways to think about it, but here's how I'm going to write you. Anyone who has a buddy, they get to go outside. If they're single, they have to stay inside. So there's a mathy way for me to explain this, but I'm going to kind of give you a little something to help you out. Think of like 20 as being inside the house. He is inside the house. And think like when you're a little kid and your mom's like, you can go outside, but you need a friend. You need a buddy. Okay? Well, these guys, they have a buddy. They have a pair. Okay? They have a friend. They get to go outside. They're going to go basically outside of the square root sign. They're going to go outside. But see this 5 here? He doesn't have another 5 to hang around. He's by himself. So he has to stay inside the radical. And that is your answer. So you make your factor tree. Anyone who has a buddy stays outside. And anyone who is single stays inside. Okay? So this is the simplified version of square root of 20. You can check that because in your calculator you could do square root of 20. If you want to look on your calculator, the square root sign is second x squared. And then type it in and hit enter. And then you could do 2 times square root of 5 and hit enter, and they'll give you the exact same number. This is what we're wanting. We do not want decimals. Okay? This step 2, there could actually be an additional step, and we'll look at that at the next example. So, same thing. I want to do the square root of 72. First thing I got to check, is 72 a perfect square? You can look through your list or just no, because 8 squared is 64, 9 squared is 81, 72 is nowhere between those. Okay, so it's not a perfect square. So I need to simplify it. Remember, step 1, you don't have to write this again, because we're going to make a factor tree. Right? Now this gets a little harder because 72 has a lot of factors. So let's say you're a kid who's like, well, I don't know what multiplies into 72. I have no idea. Well, then take your calculator and do 72 divided by some stuff, and you can get something. So I'm going to do, let's see, 72, we'll just do 8 and 9. 8 and 9 multiplied to 72. You could have found different factors. At the very end, it should still be the same. 8 can break up into 4 times 2. And 4 can break up into 2 times 2. And 9 can break up into 3 times 3. So that's step 1. I've made my factor tree. Okay? And I'm only looking at the bottom numbers. I don't look at the 8, 9, or 4 anymore. Okay? Step 2. You don't need to write this again, but just look. If they have a buddy, they go outside. And if they're single or if they're alone, they stay inside. But something is different that's going to happen on this one, and I'll show you. Okay, look. These guys have a buddy. Right? They have a buddy. These guys also have a buddy. So I have 2 buddies. So the 2's and the 3's are going to go outside. 2's and 3's are going to go outside. You do not write 23. No, not at all, okay? So if a 2 and a 3 is going to go outside, then what we do, and I'll make a little note here, you can actually write this on the here, is if there's more than one buddy, if there's more than one buddy, you multiply them. Or if there's more than one single, you would multiply that as well. Okay? So 2 times 3 is 6. That gets to go outside, and then this 2 right here, square root of 2, has to stay on the inside. Okay? So the buddies, 2 and 3 to come outside. 2 times 3 is 6. And then the 2 gets to come inside. Okay? What some of you might be asking is, well, how come you're not writing plus or minus? Okay, I get that, 100%. The reason why I'm not writing that right now is because I still have the radical here. Now, if I had a perfect square, then I would take it out and I would put plus or minus. But since I still have a radical in my answer, this square root, then I don't write it just yet. Okay? So, that's prime factorization. Let's practice it. So I have 4 different ones here. Go ahead and write those 4 down. Pause if you need to write them down. We're just going to go through them. So, first step always is make a factor tree. So what multiplies into 45? 5 times 9. And then you have 3 times 3. And I can't break up 5 at all. Okay? So, these guys have buddies. They're buddies. So the 3 goes outside, and my 5, stays on the inside. There you go. That's it. So we make a factor tree. Buddies go outside, the single guys stay inside. Okay? 98. So there's probably a lot of factors of 98, maybe. We'll see. So let's just do, if you don't know factors, you just got to divide. So I'm going to do 2. So in your calculator, you can do 98 divided by 2. And I got 2 and 49. So I can't break up the 2 and the 49. The only thing that goes into there is 7 and 7. Okay. So these guys have a buddy. Switch colors. He's a buddy. So 7 goes outside, and my 2 stays on the inside. Okay? So 7 comes outside, he has a buddy, 2 stays on the inside. If you want to check your work, put this in the calculator, hit enter, type this in the calculator, hit enter, and it should equal the exact same thing. So you can always double check. Okay? Okay, let's look at 85. So if you don't know what factors of 85 are, then we break them up. You start dividing by some stuff in the calculator. Divide by 2, divide by 3, anything you need to. And 5 works. And 5 times 17 is 85. Okay? Now here's a little special situation. I can't break up 5. I also can't break up 17 either. They're both prime. So I can't break up anything. And so there's no buddies, right? I can't take anyone outside. There's no buddies. So all I have to do is I have to leave both of these guys inside. So 5 times 17 is just square root of 85. I cannot simplify that anymore. So let me explain that one more time. I made my factor tree of 85, and I got 5 times 17. 5 times 17 goes into 85. But I can't break up 5 at all, and I can't break up 17 at all. So there are no partners that I can go outside. So everyone has to still stay inside. And 5 times 17, just 85. So that's possible. Okay? Now, 36. Things that multiply into 36. Let's see. 3 times 12. And 12 breaks up into 3 and 4. And 4 breaks up into 2 and 2. Right? So 3 times 12. 12 breaks up into 3 and 4. 4 breaks up into 2 and 2. So I have buddies here. And I have buddies here. Good. And if I take out 3 times 2, that's 6. And then there's no one left inside. There's no one left on the inside. So I don't have to put square root of anything. 6 is my answer. And that's why some of y'all were like, well, do you even have to do all this work? Because what is 36? 36 is a perfect square. So if you know it's a perfect square, you don't need to break it all up like this. Okay, you should just know if it's 36, it turns into 6. But we also know is that it's a positive or a negative 6. Okay? Positive or a negative 6. Alright? So, there's your practice. Make a factor tree. If they have buddies, they go to the outside. If they don't have buddies, they stay on the inside. I do want to give you one that's just a tiny bit more complicated, just so we can look at it together. And then we can kind of move on from there. So, actually, maybe I'm just going to do it right here. Alright, so just as like one that maybe is a little bit tricky, let's say you have a huge number, like, I don't know, 216. Square root of 216. Okay, you got a huge number there. So we're just doing a random extra practice, just so you can see how to do the larger ones. Okay, 216. Maybe you don't know what goes into 216, so you take your calculator and you start dividing it. 216 divided by 2. 2 times 108. Okay, awesome. I can't break up 2 at all, so maybe 108. I don't know, 108 divided by 2. That's 2 and 54. Or you could have divided it by 3 or by 4. It doesn't really matter. Okay. 54, I divided it and I got 3 and 18. So that's awesome. I can't break up 3, and 18 I know is 2 and 9. And then I know 9 is 3 and 3. So I have a huge factor tree now. And the higher the number, the more factors it's going to have, for the most part. So I have a lot of factors here. So I need to see if I have any buddies. Okay, so these guys can be buddies. These 3s down here can be buddies. But then I'm left with a 3 and a 2 on the inside. So on the outside, 2 times 3 is 6 square root, and a 3 and a 2 are on the inside. So I have to, if they're on the inside and I can't combine them with anything, I still have to multiply them. So 3 times 2 is also 6. Okay? So even if you have a big number here, you can put this in the calculator, hit enter, put this in the calculator, hit enter, and you know you're correct if they are the exact same. Okay? So, things to remember. What to remember? Step 1 is I want you to look for perfect squares. If it's a perfect square, you don't have to do all that prime factorization stuff, that factor tree stuff. You know already what it is, okay? But if it is a perfect square, remember, it's got to be positive or negative, whatever number it is. Because a positive number squared and a negative number squared will give you the same result, okay? The second thing, the biggest thing kids forget is you need to multiply if you take out more than one buddy. So remember what I mean by that. You can go ahead and write that down, and I'll explain what that means. If you're taking out more than one thing, like there's a group of 2s and a group of 5s, awesome. Then 2 times 5, you would take out 10. Okay, you have to multiply those two things when you put them on the outside. And then, same thing here, is you need to multiply numbers that are single, or that don't have a buddy, or anything like that. Okay? So write down, and I'll show that one more time, and then we'll be done. So look for perfect squares first, positive or negative, whatever number that is. Number 2, you multiply if you take out more than one buddy, or you multiply the numbers that are single if there's more than one of those as well. So what I mean by that, just to be clear, we'll go back to the last slide here, is like here, there was a buddy of 2s and a buddies of 3. So 2 times 3 is 6. And then there was a single of 3 and a single of 2. So 2 times 3 is 6. Okay? Alright, one last thing before you go, just to make sure we understand. Some of y'all are like, okay, I can do it, but I have no idea what's happening. Okay? The reason why this works is, you have 45, right? And we have this 3 here. So square root of what will get me 3? Well, square root of 9, right? Because 3 squared is 9. So if I have 9 and also 5, 9 times 5 gives me 45. That's what's basically happening here. You're just having to just write it like this. Okay? Now, we're only ever going to get better at something if we practice it. So now it's your turn to go practice. If you have any questions, please talk to your algebra teacher.